Let's look at an example where we're using a linear model to solve a problem. It says the percentage of American adults who smoke at T years since 1900 can be approximated by using the function g of t equals negative 0.48t plus 71. And our first question, part A, says, according to this model, what percent of American adults will smoke in the year 2025? The mistake that a lot of students make is just plugging in 2025 for t, but t, as the problem indicates, is years since 1900. So for the year 2025, we need to figure out how many years that is after 1900 by calculating 2025 minus 1900. And we get that it's 125 years after our starting year of 1900. So here what we want to find, we want to plug in 125 into our formula for t. And we have g of 125 equals negative 0.48 times 125 plus 71. So if we calculate this, negative 0.48 times, oops, I made a mistake on my calculator. Let me start over. Negative 0.48 times 125 plus 71, we end up with 11. So here our answer would be, written in words, 11% will smoke in the year 2025. Suppose we look at part B that says, according to this model, in what year will no American adults smoke? In other words, when will our percent equal 0% or 0? To do that, we take our formula for the percent that will smoke, and if we want to figure out when it will be 0, we would set that formula equal to 0. And then we're going to use algebra to solve for t. First, we subtract 71 from both sides, leaving us with negative 0.48 t equals negative 71. And now we would calculate, divide both sides by negative 0.48, and we would end up with t equals, on my calculator I have about 147.917, just to round it off to 3 decimal places or so, or right around 148, just to round it to the nearest whole number. Now this problem is asking in what year it would be. T is years since 1900, so we'll take our estimated answer of 148 and add that to 1900, and we would get our answer of 2048.